Hi there. In today's episode, we are going to discuss opportunities as a power quality engineer. If you're in the job market, you might have come across electrical engineering roles titled as power quality engineer. So what does a power quality engineer do? A power quality engineer analyzes the data, runs different types of tests and diagnosis, works with operation and maintenance teams in order to identify sources that can be causing power quality issues, and develops engineering solutions to improve system reliability and performance. One of the key aspects of this role is to properly capture the relevant data. In order to do that, you have to be well versed in the different types of tools that need to be used. There are a lot of different options when it comes to power quality meters, and these devices are very smart. In most of the cases, by properly setting up your voltage input and the current input, you can extract a lot of details about the power system by means of the power quality meters. You can program these devices to capture data at set intervals. You can also set triggers, which will allow them to capture abnormal activity. Nowadays, a lot of these power quality meters have extended battery lives, and they can also communicate wirelessly. When I used to do power quality studies, we'd have to find sources of power nearby and have these devices hooked up because of their low battery lives. And also we'd have to use SD cards. Now, depending on the facility where you are conducting power quality study, if there's a lot of metal structure around and the Wi-Fi connectivity is not present, you may still have to resort to capturing the data locally in the form of SD drives or USBs. But if you're in a commercial setting, a hospital building, an office building, and an area where Wi-Fi connectivity is not an issue, you can actually do real-time monitoring of the data that is being recorded by these power quality meters. A lot of times, the reason why we need power quality studies is because of equipment malfunction. In our daily lives, the use of electronic devices is on the rise in residential, commercial, as well as industrial settings. In the residential setting, we are using our laptops, all of our appliances such as refrigerators, washing machines, dryers, even smartphones. They all have different levels of power electronics in them. Similarly, in the commercial settings, you have chillers, HVAC, LED lighting. All of these loads have non-linear component in them which produce harmonics. And obviously in the industrial setting, things only become bigger and much more consequential with the use of large VFDs, UPSs, battery chargers, inverters, and a variety of different types of power electronic equipment. All of this translates into deviation from your nice looking sinusoidal waveform for voltage and current. Harmonics can create a lot of problems for motors, transformers, generators, cables, capacitor banks. One of the most noticeable symptom of presence of excessive harmonics in a power systems is heating, which can result in premature failure of big ticket electrical equipment such as transformers, motors, and generators, all of which can be extremely costly. You can also have equipment malfunction, vibration, insulation damage, resonance, and a lot of other undesirable occurrences. As a power quality engineer, you basically go on a detective mission. You hook up the meters, collect data, analyze the results, identify the problem, and provide actions that can help mitigate the problem. So how do you become a power quality engineer? Typically, you'll have 4 years of undergraduate engineering, a very sound foundation of power systems, understanding the three-phase systems, single-phase systems, different configurations, delta, Y, grounded, ungrounded systems, familiarity with different types of electrical equipment, installations, field knowledge, understanding of processes, operation and maintenance requirements, maybe experience with power system studies, being comfortable using these tools, because sometimes when you're hooking up this equipment, you actually have to get close and personal with different types of electrical equipment, understanding of electrical safety requirements, code compliance, and above all, training in power quality. Being exposed to different types of scenarios, working with senior engineers, going through diagnostics exercises, and in many cases also working with the vendors, talking to VFD suppliers, UPS manufacturers, switchgear suppliers. In short, you need a broad cross-section of knowledge, experience, and expertise in order to become a good power quality engineer. This role combines theory, application, and a lot of field knowledge, which means that you will get the best of both worlds as you progress in this career. And there are tons of opportunities out there. The use of electronics is only going to increase, and these problems are going to become more and more severe. So we need power quality engineers who have theoretical understanding, field knowledge, and can apply all of this in order to produce solutions for these real world problems. And if you want to learn more about preparation of FE Electrical and Computer exam and the P-Power exam, then check out these playlists over here. Thanks for watching, and I'll see you soon in the next video.